Here, we are going to see if the matrix or the resulting matrix for the set of operations, whether it's defined or not. Take note that we are given with the size of the matrix A, B, C, D, and E, and all of them are subjected into specific operations. So let's start with number 1, the product of B and A. When you have this situation here, the product of B and A should be the product of their sizes as well. So B is 4 by 5. A is also 4 by 5. In this situation, when you this BA is actually under multiplication of matrices, it should be the result should be defined if the inner entries here are the same, because it should be m times r and r times n. You will get m by n matrix. And since here we have different sizes for our number of rows to columns for the result of B and A, this is undefined. In short, there can be no result for BA with this given sizes of the matrix. We don't have the exact entries of the matrices, just the sizes, but we can automatically say it's undefined. Next here is the product of A and BT. The BT is actually the transpose of B. Okay, transpose of B will allow us to interchange the number of rows and columns. And as for that, since we also have A, D, and E here on the remaining items, let's also try to write here the transpose of A, transpose of B, transpose of C, transpose of D, and transpose of T. We're just going to interchange the number of rows and columns. So instead of A being 4 by 5, your transpose of A is 5 by 4. For the transpose of B, again, your B is 4 by 5. You also get 5 by 4. For your transpose of C, your C is 5 by 2. Its transpose is 2 by 5. For D, you have 4 by 2. Its transpose is 2 by 4. And finally, for your E, which is 5 by 4, its transpose is 4 by 5. So we have these transposes here. So looking back to our number 2, our A is 4 by 5 to be multiplied with your transpose of B, which is 5 by 4 as given here. Now, as you can see, the entries here are just the same, so we could cancel it out. The resulting matrix for the product of A and transpose of B is a 4 by 4 matrix. No matter what type of matrix it is or the entries are, it's a 4 by 4 matrix. Next, for AC plus D. So A is 4 by 5 and your C is 5 by 2. So their product is defined as 4 by 2. Okay? We're not yet done. This is just a product of A and C. But we are going to add it to D. D is 4 by 2 as well. Okay? But if you are going to add, you don't need to look into the inner values here. When you add, it's only defined if the sizes are the same. Noticeably, the result of AC is 4 by 2 and your matrix D is also 4 by 2. In short, the result of the entire operation here is defined and the resulting size is also 4 by 2. For subtraction and addition of matrices, they must have the same same sizes. Okay. Next, E times AC. Let's start with AC first, okay, because of the grouping symbol. So for AC, A is 4 by 5 and your C is 5 by 2. So AC is defined as 4 by 2. This is your AC. But we are going to multiply that to E. Okay, so don't worry about this entries here. I still have spaces at the bottom, so let me write it here. So E times AC. Your E is 5 by 4. Your AC earlier is 4 by 2. So since we have the same entries here, the resulting matrix for the operation E times the product of AC is a defined matrix with size 5 by 2. Okay? So you can just simply do it step by step. Next, for number 5, I have A minus 3 times the transpose of T. We know that A is 4 by 5. And it's to be subtracted with 3 times the transpose of E. But the transpose of E, look at the transpose of E, okay? The transpose of E is 4 by 5. No matter what the scalar is, it won't change the size of 4 by 5. So when you subtract that, okay, subtract, A is 4 by 5. And then your E, or your transpose of E rather, is also a 4 by 5. And no matter, again, even if you're going to subject it to scalar multiple of 3, it's still 4 by 5. So their difference is defined as a matrix, resulting matrix of size 4 by 5 as well. Okay? So these are for the first 5 items. For number 6, we have E times 5B plus A. Okay? So let's start with 5B. Again, this is a scalar multiple, but let's just look at the size of B. That's 4 by 5. So it's a 4 by 5 matrix. Plus your A, which is also a 4 by 5 matrix. In short, their sum is defined as a 4 by 5 matrix because, again, addition would need the same sizes. But this is to be multiplied with E. And E earlier is 5 by 4. So you have a 5 by 4 matrix to be multiplied with the result 4 by 5. So our resulting matrix for the entire operation is a 5 by 5 matrix. And it's defined. Okay? So for the first 6, only the first item is undefined. The rest, number 2, 3, 4, 5, and 6, are all defined. Let's proceed to number 7. Number 7 is this. Okay? So number 7 is the product of C and the transpose of T. C is a 5 by 2 matrix. So it's a 5 by 2 matrix. And the transpose of D is a 2 by 4 matrix. So you have 2 by 4. So you have this. Their product is defined and it's a 5 by 4 matrix. Number 8. Number 8 is DC. So D earlier is a 4 by 2 matrix. It's a 4 by 2 matrix. And C is a 5 by 2 matrix. So these are not the same. So your resulting matrix is undefined. Next, let's have number 9. BC minus a 3D. BC minus a 3D. So let's start with BC. Let's look at B, is 4 by 5 matrix. It's a 4 by 5 matrix times C, which is a 5 by 2. So you move that out. BC is 4 by 2 matrix. But you're going to subtract this to 3D. And your D is a 4 by 2 matrix. 4 by 2 matrix. Since the operation is subtraction, we just need the same sizes that they are. So the result for number 9 is also a defined matrix with size 4 by 2. Okay. Number 10. So we're almost done. Number 10 is the product of the transpose of D and the result of B and E. Let's start with B, E. B is a 4 by 5 matrix. 4 by 5. Okay. So it's a 4 by 5 matrix, and E is a 5 by 4 matrix. As you can see here, 5 by 4 matrix. So you remove that, your BE is a 4 by 4 matrix. But this is to be multiplied with the transpose of D, which is a 2 by 4 matrix here. Right? So it's a 2 by 4 matrix. Same. So your result here is a defined matrix with size 2 by 4. 11. 11 is a transpose of B times D plus E, D. Okay? So B, or transpose of B, okay, so pardon if I'm going to scroll down, scroll up from time to time. 5 by 4. Here it is. 5 by 4. So BT is 5 by 4. And your D, we have D here earlier. So you have 4 by 2. So their product is defined as a 5 by 2 matrix. Your E is a 5 by 4 matrix. And again, your D is a 4 by 2 matrix. Cancel that. You have 5 by 2. Add, same sizes. It's a defined matrix by 5 by 2 size. Let's have the last item here, 12. B times the transpose of A, B transpose of A plus D. We know that B is a 4 by 5 matrix here. 4 by 5 matrix. Okay. The transpose of T is a 5 by 4 matrix. So 5 by 4. So the result of B times the transpose of A is a 4 by 4 matrix. Plus D. Your D is actually a 4 by 2. We cannot do this one here and cancel them because we are under addition. This means that the result here is an undefined matrix. Now, this might seem too long, but the point of understanding this is before we go to the operations later, we must need to know whether the matrices of the result would be defined or not. Because if in the first place they are undefined, just like in number 1, what else? Just like in number 8, if they, and number 12, if they are all undefined, you don't need to solve them as to the exact entries of the result, since you're already sure that they are undefined. So this is all about seeing or looking into the relationship of the result of the operation and describing whether they are defined or undefined matrix, and giving the size of the defined matrices. Thank you for watching.